Yeah. All right, I'm going live with Facebook.
Okay.
But we'll wait, until 10 so that the Zoom people can all log in.
Okay. Oh yeah, I mean, I'm good. Whenever you just give me the thumbs up and I'll go.
As soon as I'm live on Facebook, I will. All right, I think we're live. I'm going to hit start webinar so people can start logging in.
Okay.
One time I forgot I was in a practice session. I did my intro and everything, and then I see this thing that says, "You're in practice session. Would you like to start the webinar?" I was like, I thought I already did.
Round 2. Well, now you're like a seasoned professional at this, right?
All right, we are live. Good morning, everybody that's on Facebook. We're just going to wait until 10 o'clock while our Zoom guests are logging in. And they're already starting. We're up to 6 already, so.
Awesome.
It's a very different day at Ham and Acid today. Everybody can look at all of the rain and no people. Past few weeks, there's been lots of people following the Red Cross bills around from tree to tree. Looks like Belgrade just logged in.
Nice.
It's evening over there.
Oh, wow. Good evening.
Michigan is here.
Oh, cool.
Everybody on Facebook, if you want to post up where you're messaging from, I always like to see how far it's reaching. North Haven is on.
Nice.
All right, what are we up to? We've got, let's see, 10 people on Zoom and 53 on Facebook.
Awesome. I think a good handful of that is my family, so I'll shout out hi to them right now.
Yeah, my mom's watching.
I'm sure my mom's probably watching too.
Say good morning to all the moms out there.
Yeah, seriously.
Jennifer would like to know if this will be recorded, and it will be on the Facebook live stream, and then eventually it will get onto the website. You'll be able to watch it later on the website. Lisbon, Connecticut.
Nice.
Exeter, New Hampshire.
Ooh, nice. Love
Last
Exeter.
week we had every New England state except New Hampshire, and then when I said that, then I had a whole bunch of people say they were from New Hampshire watching.
Nice. Good to have all the northeastern states on there. Especially a lot of this stuff it's from Connecticut, but definitely applicable to most northeastern states that share the same seasons and habitat.
Patty Clifton says hi.
Hi, Patty. Ah.
She calls you Nature Megan?
Yeah. Yeah, so Patty Clifton runs a Deer Lake Day Camp, and I worked there for God, a long time as a counselor and then as their nature director. And it's actually where I met my husband, who's in the other room. So thanks, Patty.
Cool.
Matchmaker.
Yeah, my first 2 summers out of college, actually one in college and then the first one out was at a summer camp. It's awesome.
So much fun. It's like, I remember we were like, we get paid to do this. This is the best ever. Just
Yeah.
like outside all day. Then when I was nature director, it's like so much fun to just teach these kids about like being outside and having an appreciation for the natural world. And yeah, it's just an awesome job. And they're great there too. I haven't been there in so long, but it's a beautiful facility. Lots of great land.
So again, for everyone logging in, we are going to wait till 10 o'clock so that everybody has a chance to log in, and then we'll get started. Patty says thank you. Couple of more minutes. Greenville, South Carolina.
Oh, cool.
Atlanta, Georgia.
Nice. I went to Atlanta a couple of years ago for a conference. They have the coolest aquarium by far.
I haven't been there.
It's awesome. We missed it, but like they have the whale sharks and stuff there. It's like to have a facility like that is like crazy. Like how can you contain a whale shark, right?
That's something on my bucket list, is to see a whale shark. I've never seen one.
Same. That's like I'd love to see them out in the wild somewhere. That's like ultimate life bucket list. Like I'll be doing that when I turn 99.
So before we get officially started, was a question about using these videos in a classroom. And the Nature Center has on the website at meigspointnaturecenter.org in the Virtual Learning Center, there's, I think, over 300 videos now. Each of those videos has additional content with them. Things like crossword puzzles, vocabulary lists that are open and welcome to be used in classrooms. So
And I have my email listed on the bottom here, and then I'll have more contact info at the end of the presentation. But if anybody needs to reach out for additional information or images or anything like that, please feel free to contact me.
Nevada just chimed in on Facebook.
Who did?
Nevada.
Oh, Nevada. I heard Heard like rum chata or something. I don't even know. Hi, Nevada.
Minden, Nevada.
Nice.
All right, I think we can get started.
Okay.
So first of all, I want to welcome everybody who's tuned in on Facebook and on Zoom for another presentation from the Meigs Point Nature Center. And I want to give a shout out to the Friends of Hammonasset who support and sponsor us, especially during this COVID time. They are paying to feed all of the animals that are at the Nature Center. So a big shout out to them for all of their hard work and money. So today's program is another one of our wildlife programs, which are happening every Saturday at 10 o'clock. Through March, we've got wildlife, and then we're going to move on to other topics for April and May. We'll still be throwing some wildlife in throughout those. But if you're interested in signing up for any of the future programs, you can visit meigspointnaturecenter.org. Go to the programs. Under that, you can click on calendar and then choose the event you want. You can hit a message to have the Zoom link sent to you, or you can subscribe to the calendar and get updates sent to you as soon as they're put up. So please continue to do that. My programs occur Tuesday through Friday at 11 o'clock, so continue to tune in and watch those live. And I think that's it for my commercials. So let's get to our presenter. We have Dr. Megan Linsky from the Connecticut Ag Experiment Station. And actually, she has all her information right on the first screen, so I don't even have to say anything. But this is a program on backyard wildlife diversity, which is a subject that's very interesting to me. I love to see wildlife, especially wildlife in my own backyard. So with that, take it away.
Thank you so much for the introduction. And thank you guys so much for having me here today, and all the people who are tuning in, not only from neighboring Connecticut towns, but across the country and even across the world. It's very exciting. It's a whole new lens doing these virtual talks. So I hope you enjoy it. I definitely do, because this is the best job ever. So just to give you guys a little context of who I am and what I'm going to be talking about today and kind of the logic behind it. So hi, I'm Dr. Megan Linsky. I am a postdoc at the Connecticut Agricultural Experiment Station. So my background is in wildlife biology, but I specifically look at zoonotic diseases and vector-borne diseases and the ecology of those diseases. Specifically, I look at Lyme disease ecology. So I look at how wildlife and habitat play a role in the density and distribution of the vector that causes Lyme disease, which is the black-legged tick, and then also other associated pathogens. So of course, I got to start every presentation with a good old tick pun. So if you live in Connecticut, as well as many states actually in the Mideast, in the western parts of the US, and actually a lot of other countries too, I've actually talked to a lot of people in Scotland who have similar issues. We have a big tick problem. If you are from Connecticut, I'm sure that you have either had Lyme disease or know somebody who has had Lyme disease. Usually this is the part of our in-person talk where everybody raises their hand and we all feel some sense of solidarity in having tackled this disease together. But overall, we have about 16 different species of ticks in Connecticut, 3 of which are known to bite humans, but only 4 have been able to transmit pathogens that cause diseases. There are a couple of other exotic species, but that's not going to be the focus of this talk today. What we're really going to look at is the black-legged tick and its ties to wildlife diversity. And I'll talk more as we go through, but there was a specific study that we did kind of tying what we're seeing in people's backyards to the density of black-legged ticks and the presence of the pathogen that causes Lyme disease. So, as I said before, a lot of people have had Lyme disease or another tick-borne illness, and it's I'm not sure what you guys are seeing versus what I'm seeing. My little video might be cutting off the final bar there, but tick-borne illnesses have been continuously on the rise throughout the United States. If you look at a map It's typically concentrated in northeastern, or I should say Lyme disease is concentrated in the northeastern United States, but it's spread throughout much of the United States as well. So when you're looking at these numbers, so we have upwards of 60,000 cases in 2017. About 40,000 of those cases are just Lyme disease. So this is why this tends to be the focal point of a lot of tick-borne disease research and looking at things like Lyme disease ecology. And I should also note that it says it's 40,000 reported cases, but they say that the actual number of cases is closer to 400,000. And this is just from reports from 2017, 2018. So it's most likely gone up since then as well. So just to kind of give some context as to why people seem hyper-focused on black-legged ticks and Lyme disease and looking at solutions to reduce human cases of it. And so not only are we seeing an increase in the density of these ticks and their associated diseases, but we're also seeing an increase in their, or an expansion in their distribution. So they used to be really concentrated towards the coastal regions of the Northeast, but they've spread substantially. They're moving more north, south, east, west, you name it. Not in the ocean yet, so don't worry about that, but they are spreading pretty rapidly, and it's only getting worse. So that's kind of where my job comes in. I look at the different factors that cause this increased distribution and density of the species. And so what we've been finding is while there's not too much progress on the medical side of Lyme disease, there's diagnostics and clinical settings, and they're trying to come up with vaccines for it, or they have that haven't worked. And they have a treatment strategy. The best way to tackle ticks and tick-borne diseases is to look at it from the ecological standpoint. And so when we do that, we have to look at factors such as host, habitat, and things like climate. And so that's kind of be the focus of this talk, and the study that I'm going to be discussing today is looking specifically at the host and habitat dynamic and how there's this interplay at work and how it changes between woodlands and backyards. So when we're looking at hosts, or wildlife, I should say, we're looking at things like diversity and density of certain species. Deer are kind of a flagship species for ticks and tick-borne diseases. We're also looking at something called competency, which I'm going to talk about, I think, in the next slide, and host movement. And then for habitat, we're looking at things like composition and structure. We're also looking at the fact that in states like Connecticut, which were predominant or historically agricultural areas, we've had a lot of reforestation that occurs, and this has caused an alteration to our natural habitat, specifically looking at our woodlands. And as a result, we have a lot of invasive plant species. We don't have quite the heterogeneity or diversity just in our landscape that is required for a healthy woodland ecosystem. And on top of it all, we have a lot of species that have now adapted to this environment, and that's kind of going to be the focus of this conversation that we'll be having. So let's focus in on this black-legged tick for a hot second. So I know most of you have probably seen this tick, probably don't want to see this tick, but you do see it. It's also known as the deer tick. So if you've heard that more common slang name, they're the same species. They're known as, or the scientific name is Ixodes scapularis. They have 4 life stages: egg, larvae, nymph, and adult. And the adult they separate into male and female. This picture here is of an adult female. So if you ever see that kind of reddish brown bottom, that's a female tick. Those are the ones you have to worry about. And they are the primary vector, excuse me, for Borrelia burgdorferi, which is the pathogen that causes Lyme disease. And so the 2 life stages that we have to be concerned with when we're worried about contracting this pathogen is the nymphal life stage and the adult female life stage. Oh, and this is just a shot of the actual spirochete Borrelia burgdorferi. This is the bacteria that causes Lyme disease, just in case you wanted to know what that looked like. So the reason we have to look at these specific life stages is because this tick has a 2-year life cycle. So in that 2 years, basically once they hatch from egg to larvae, they have to obtain a blood meal in order to continue their life cycle. So when they hatch from egg to larvae, the larvae are basically pathogen free. They don't have any pathogens. So if you get bit by a larvae, yes, they'll give you the heebie-jeebies, but you're probably not going to contract anything. But when they obtain that initial blood meal, that's their first opportunity to uptake a pathogen, such as the ones that cause Lyme disease. So typically, because larvae are really, really small, if you've ever seen them, they're like the size of the period at the end of the sentence. They have to feed on small host species. So this is birds, small mammals like rodents, squirrels, mice, that sort of thing. Once they've obtained that blood meal, they'll molt and turn into a nymph. So now the nymph is the first epidemiologically important life stage, because this is the one that has now obtained a blood meal and now possibly has the pathogen within their system. So the next host, or the next wildlife species or human species that they feed on, will now be able, they could potentially take up that pathogen. So the nymphs can now feed on small mammal or small host species like the birds and the rodents that we talked about. They can also feed on some larger species like fox, deer, dogs, cats, and humans. And they typically, as you can see here in this little spiral, they typically come out in late spring, early summer. So this is usually when humans are becoming most active as well, because the weather's getting warmer, they want to get outside. And so this is when you're most likely to contract the pathogen that causes Lyme disease, because these guys are the first ones out there, and they're also potentially carrying the pathogens that cause these diseases, and they're really, really small still, so they're really hard to see. Once they've obtained that blood meal, so now this is their second one, they have once again had another opportunity to uptake more pathogens before they molt into an adult. And then, as you can see in that lower picture, there's males and females. The males won't feed again, but the females will. And so the females will need a larger bodied host. This is deer, maybe some fox and coyote, and then humans. And so they have a greater percentage of having pathogens that cause tick-borne diseases, but because they're larger and they're typically come out in the fall, maybe early spring, you're more likely to notice them on your person, but also your likelihood of encountering them is a little less because you're not out in the woods as much. So still important, but just so you guys get an idea of not only when they're uptaking the pathogens, but they have multiple feedings in which they need to encounter a host species. So very important in the life cycle. So whenever they encounter, so let's see, when the larvae feed, when the nymphs feed, and when the adult female feeds, when they encounter hosts typically fall into two categories: competent and incompetent. So a competent host, and I think that's my next picture here. A competent host is one that when a tick is feeding on it, if this host, let's say this is a white-footed mouse, so this is a primary reservoir host for our early stages, think larvae and nymph. A white-footed mouse is an incredibly competent species, meaning that if that mouse has the pathogen that causes Lyme disease, Borrelia burgdorferi, and a tick feeds on it, that tick will uptake the pathogen from it. So pretty much anything that's feeding on that mouse will get the pathogens that cause Lyme disease, which is not great. That is a competent reservoir host. And so, like I said, this guy gets, as you can see on this picture, let's see, oh, I can't have my mouse. So white-footed mice tend to be the primary reservoir host for black-legged ticks because they feed the early life stages of larvae and nymph, and they tend to be pretty highly infected with pathogens like Borrelia. So then all these ticks, you can see here, we got probably like 3, 4, 5, 6, 7, 8, 9, at least 20 ticks just on its ear, a couple around its eye, and then its whiskers. Those are now all potentially infected. So when they molt and go into the next life stage, and if they feed on you, you could become infected. So that's what a competent reservoir host is. Incompetent reservoir hosts are ones that can have a tick feeding on them, even potentially an infected tick that could pass on a pathogen, but no subsequent feeding ticks can pick up pathogens from that host. So white-tailed deer are kind of our poster child for this. Humans are as well, and I believe dogs and cats too. So they can be, let's say I am infected with Borrelia, I've had Lyme disease, and a tick that's uninfected feeds off of me. It won't be able to pick up any of those pathogens from me. So that's what makes the difference between competent and incompetent. Competent can pass pathogens back to feeding ticks, incompetent cannot. So this is an important distinction to make between species because it's going to tie into our whole talk about backyard diversity and how it influences ticks and tick-borne diseases because of this theory or this concept called dilution theory. So the idea behind it is that when you have an increased level of diversity or unique species on the landscape, it's increased opportunity for ticks to feed on both incompetent and competent reservoir hosts, which means you're kind of diluting out pathogens. So if they're encountering more incompetent species, they're less likely to pick up pathogens and pass them back and forth. So they're still feeding, propagating the tick populations, but they're not spreading the pathogens that cause diseases. So, like I said, the idea being increased diversity, less pathogen presence. But then there's one more part of this theory that's tied into landscape. So specifically, the theory ties into the fact that they think in woodland environments, so all the woods around you that are not developed and there's no residential indicators with them, even trails, stuff like that. They think that in woodland environments, you're going to see a greater level of diversity and therefore less pathogen presence versus in more developed areas, think your neighborhoods, community centers, that sort of thing, you're going to see a reduction in diversity and an increase in pathogen presence. Okay. And so this all ties into the fact that with in woodlands, you think you have these wide open spaces for all these different species to exist and be happy and healthy in a balanced environment. And so that's why you're seeing the diversity. And so you'd think that there'd be less disease on the landscape versus in stereotypical fragmented or developed areas, there's less area for wildlife to inhabit or survive or find a food source. And therefore that diversity goes down. And so the idea would be that ticks are primarily feeding on the remaining species like mice, which are a little bit more generally spread throughout habitats. They're, pretty resilient. I'm sure many of you have had a couple mice in your house like I have. So you know that they can pretty much live anywhere and everywhere. So that's this idea of dilution theory. It kind of connects how we're looking at wildlife and its role in the spread of tick-borne diseases. So just to kind of break it down one step further. So we have our vector, our tick. And so when it encounters a competent host versus an incompetent host, this is where the cycle of pathogen transmission diverges. So when it encounters that competent host, it's increasing pathogen presence across the landscape. And that's resulting in increased Lyme disease cases in our human population. Conversely, if you're looking at incompetent hosts like white-tailed deer, like I said, I listed a couple domestic species, but there's a lot of wildlife species like coyotes, I believe, coyotes, skunks, certain bird species, woodchucks, foxes, there's a whole list of them. But basically with increased diversity, you're going to see more incompetent species on the landscape. You're going to see a reduction in that pathogen presence or pathogen dilution, and then therefore you should see a reduction in Lyme disease cases in surrounding public areas. So tying all the pieces together, we're looking at host habitat and how it plays into vector-borne disease transmission. So the problem with this, and this is kind of where our study came in, and don't worry, we're getting to the good part soon, is we're not seeing this healthy woodland ecosystem that a lot of this theory is tied into. So it makes sense that we'd want to see more, we'd see more diversity in our woodland ecosystems if we had that healthy woodland, which we're just not seeing. So this whole study actually started with me and my team going out and reading about these papers and this theory and this concept tied into vector-borne diseases. And we saw a lot of landscapes like this. So this is a typical picture of our woodland ecosystem in Connecticut, and I'm sure actually much of the Northeast and many other areas where we don't have that that layering occurring in our woodlands. It's mostly mature forest stands, old tree stands, not a lot of understory, and there's just not that diversity that a lot of these wildlife species require in order to survive and thrive. Like, can you imagine a prey species walking through the woods here and how easily it could be picked off by a predator? Yeah, pretty simple. So what we were finding on the opposite end of the spectrum is that in our residential areas, there was much greater habitat diversity, and there's just more, what's the word I'm looking for? More of a mosaic, if you will. So there was patches, there was tree stands, ornamental plants, you name it. So just some things just weren't adding up. In addition to all that, it's assuming that a lot of wildlife species are trying to get away from people, and we just weren't seeing that anymore as well. A lot of the species that we find in Connecticut and throughout much of the Northeast have become habituated to people and very tolerant of living right alongside residential areas, so they're not driven into the woods, and especially if the woods aren't very hospitable. So we decided to do a little bit of investigating further. And this just kind of reiterates it and shows the difference between these woodland areas and in our residential areas. So woodlands, we have mature old tree stands, not a lot of layering, not a lot of area for species to hide out, seek shelter, food sources, that sort of thing. And like I said, a lot of the places where you do find an understory, it's predominantly invasive plant species, so not very healthy. On the other end of things, when we're looking through a lot of the residential areas throughout Connecticut, where it tends to be a really woodland residential area, we're built right into the woodland landscape. There's islands, edges, woods, open land, hedges, a lot of ornamental plant species that provide great food sources, or nesting habitat or ground cover. So it's almost as if there's a little bit better habitat in people's backyards versus in the woods. Doesn't make a lot of sense, but if you're looking at this from a more visual standpoint, you can see where this is coming from. And then if you're looking at it from an aerial point of view, which we also did, so these are two of our sites that we used in this study. The first one, I forget the acreage, it's a couple thousand acres of undisturbed land that people don't have access to on the top here. And if you look at it, once again, this is predominantly mature woodland stands. There's not a lot of understory. Clearly, this is probably during the winter time or late fall, so the foliage is gone. You can see right to the ground. Not much going on. However, if you look at this residential area, like I said, that mosaic, that patch effect, there's open land, woodland, shrubs. There's lots of little patches here of just diversity in and of itself, which from a wildlife standpoint is much, much more hospitable than this area up here. So we wanted to put this theory to the test. We wanted to look at this concept of dilution, its effects on ticks and tick-borne diseases, and comparing it between woodlands and people's backyards and seeing if we were seeing that same level of wildlife diversity or how it changed between those two different landscapes. So this study was in 2015 and 2016, so a couple of years ago, but still stands true today. We had 30 residential properties that participated in Reading, Connecticut, and then we scattered the rest through 18 different woodland properties. And I think you can see a couple of them here. They're all geographically spaced throughout the state. So we got a representative sample of some of these woodland environments. And we broke this into two categories. We had small mammal trapping, which was live trapping. They were released afterwards. And then we also had medium mammal, or medium to large, I should say, camera trapping. So this kind of covered the full gamut of species that we wanted to observe in people's backyards and in woodland environments. And so when we captured these small mammals, which were predominantly, I would say like 99% of them were white-footed mice, we also took an inventory of the number of ticks that were feeding on them to do a comparison between the two different habitat types. And we also took a blood sample because we wanted to see, we kind of use the mice as a, what we call a sentinel species for pathogen presence. So we wanted to determine if there's a difference in the presence of the pathogen that causes Lyme disease between woodland habitats and residential habitats, and then also tying that into where we might see more wildlife diversity or just overall abundance of unique species. So this is the fun part, my favorite part. So we put all these camera traps and got an amazing assortment of photos, thousands and thousands of photos each year that we did this. And I'm going to preface this by saying that all the camera photos that I'm about to show you are from people's backyards. So we didn't get as many in woodland properties, and the few that we did get were just not great quality photos. But in people's backyards, we found this incredible amount of wildlife diversity. And you're going to see it right now. We got the full gamut from small, medium, large, and everything in between. So obviously this is a blurry image, but we got a lot of skunks. I'm glad that we caught this on a camera trap versus me being in person catching this skunk. We also found a lot of bear. We also found, outside of camera trapping, a lot of track and sign of them. And so this is, once again, these are in people's backyards, not in our woodland properties. I don't think we got a single photo of a bear in our woodland properties, but we got several in people's backyards. And this is a pretty big guy. And then this one's always interesting to see because this little blurry guy over here, he's wearing an ear tag because this is one of our tagged bears. And what's also interesting about this photo is about maybe a half hour before it was taken, a woman was walking her dog through her backyard in that same spot. So he clearly smelled the presence of a dog and decided to come investigate further. We found other carnivore species, mesocarnivore species, a lot of coyotes of varying sizes, especially in people's backyards. This site in particular was really great because it's very characteristic of Connecticut and much of the Northeast. Like I said, we were largely and historically agricultural, so there's a lot of these stone walls fixated throughout our landscape. And I found that this one in particular became a wildlife highway. We had lots and lots of animals just kind of zooming up and down this, and got some good photos. This one woodchuck in particular was great. I think he got fatter every time that we took a picture of him. And because there was a lot of these prey species going along, we also had a lot of carnivore predatory species kind of zooming back through as well. Bobcats in particular were a really surprising species that we saw pop up a lot in our photos. And there were different, not the same individual, just kind of traveling the same loop, but multiple individuals, multiple people's backyards, and doing all sorts of really cool and interesting behavior. So this one was definitely investigating that wildlife highway of a stone wall and seeing if you can catch anything. This guy was very successful. This actually looks like a younger kit bobcat who we watched chase down. In one image, watched chase the squirrel away, and then clearly was very successful in its hunts. This one who found our camera trap was very interested in it. And then this one was definitely my favorite. I think it's especially important to note that when we were taking these pictures, the fact that we saw all these unique carnivore predatory species in people's backyards and not in woodlands was really, really interesting to note. Not to mention it made for really, really great photos. We had a lot of fox that were very interested. I'm sure lots of you guys have seen these in your backyards or in your neighborhood or community. They're very interested in the stakes. Oh, I shouldn't mention, forgot that I did not mention this earlier. We put stakes out with a pretty low-key scent lure. This was just basically to draw anything in the immediate vicinity in front of the camera trap path. So a couple of the foxes and even the bear decided that this was a great rub stick and knocked it to the ground, and we had to go reset them back up, but they survived. And they were also a great indicator to look at sizes of certain species. We also saw a lot of turkey. Fun fact about the turkeys was they were one of the few species that actually noticed the camera. And I have a lot of pictures of turkeys kind of giving me the eyeball really close. There were a lot of bird species in general, a lot of passerine species that we noticed coming in and out of people's backyards. A lot of raptor species as well coming in. Once again, predators kind of coming in and checking out what prey species are happening to these areas. Got some interesting late night photos of deer. If you're from Connecticut or any neighboring area, you know that we have a lot of deer. So it was not a surprise to see them. It was a surprise to see that there was a lot, or actually I should say a comparable amount in our woodland environments compared to our residential areas, but definitely more age diversity and activity in our residential areas. See a nice male here. And we had several fawns. I think we had one set of twins at one point too. And then it's also important to note that just because we're looking at wildlife diversity doesn't mean that domestic species are counted out. If you have cats and dogs that are in your backyard or outside, they're part of the tick life cycle and the pathogen transmission cycle for those diseases. So this cat definitely became part of our wildlife diversity tally, as was this cat. And this dog, who's very cute. And then one of my favorites is this guy. So like I said, if you have animals, I'm sure if you have animals, you've seen ticks, even if you've treated them. They do play a role in the propagation of the tick species, as well as the transmission of any pathogens that they carry. And interesting to note that dogs, horses, I'm not sure what other domestic species can contract Lyme disease. They show the signs and symptoms of the disease, but cats do not. And we also can't discount humans. Humans are part of the equation as well. So we had a lot of landscapers in these properties, and if they pick up a tick, it once again it counts as part of the cycle. They are counted as part of our backyard wildlife diversity, even some of the more adolescent cohorts. So it was a really interesting study to look at all these different species across the gamut and see how they differ between our residential and woodland properties. And most people I think assume that our woodland areas have this high level of diversity and that they're staying away from residential areas. But as you can see by this relative abundance curve, that's just not the case. So if we're looking at residential versus woodland areas, pretty much every category of species that we saw, there was more of them in residential areas. Some of the ones that we saw a little bit more were coyotes, turkeys, and some of our pasturine species, and deer, like I said, but predominantly there are more species or species that were only in residential areas compared to our woodland sites. And so when we revisit that whole concept of dilution theory and the concepts that they presented originally, they were saying that you would see more of this diversity in woodland versus residential, and we just didn't see that. In our residential areas, we saw significantly more unique species. So that's just not the number of each one, but just across the board, how many did we count? How many unique species? And then once again, we almost saw double the amount of just unique encounters. So this is an important differentiation to make, because while we want that diversity to dilute out pathogen presence, we also need to make note of the fact that black-legged ticks are passive obligate feeders is what we call, or parasites is what we call them. So they're not waiting to seek out a particular species. They literally just stand out on a piece of vegetation with their arms outstretched, waiting for something to pass by. So this diversity piece of it, it's not so much the number of unique species that we want to see, but the proportion of competent to incompetent species. So they're not going to wait around and be like, okay, I'm just waiting for a deer. I know that it's incompetent, but the likelihood of them encountering an incompetent species would just increase if there were just more animals on the landscape and a greater diversity of them overall. So that's just important to note. And then when we look specifically at, like I said, we use the mice as kind of a sentinel species for the pathogen presence and overall disease prevalence. When we looked at that, I'm sorry, I switched the bars here, so the orientation is a little funky, but there were more mice infected or with this pathogen present in their system in our woodland environments compared to our residential environments. So this is huge. This is basically saying that all these animals would rather hang out in your backyard than hang out in woodland environments. And this has a pretty big influence on ticks and tick-borne diseases. And so when we take that step back and we look at what we just found out in the greater context of things, it's really cool that we have all of these wildlife species in our backyard, but it's also kind of a red flag for our woodland ecosystems. That shouldn't be the case. We should really be seeing more of this diversity in our woodland environments and kind of just seeing that wildlife diversity skirting into our residential areas. It also goes back to that original dilution theory concept that focused on fragmented landscapes. And I think it's important that we make a comment on that as well, because fragmentation tends to have this negative connotation. And it's not always the case. When you look at a lot of our New England residential areas, we're a community that's built into the woods, right? So it's not that we're causing a lot of deforestation or breakdown of habitat, but we're breaking up that habitat, and we're causing that patchiness and that diversity that we're not seeing in the woodlands. And so that's why we're seeing a little bit greater diversity in our backyards and a little bit less pathogen presence. So it's this really interesting relationship that we have going on here. But I think it also needs a little balancing out. So I think it's great that we have this diversity and habitat mosaic going on in our backyards that's edging into the woodlands, but I do think that we need to focus on reestablishing a healthier woodland ecosystem and bringing some of that heterogeneity, that layering back into our woodlands to kind of draw back some of that diversity. And I don't think that'll negatively have a negative effect on our backyards and how you know, seeing that wildlife in our backyards and that reduction in pathogen presence, if anything, I think it will just allow for this expansion of diversity and for the reduction of pathogen presence in our woodland environments that we need to see across the board, if that makes sense. And then from a non-vector ecology standpoint, at some point, having all of this wildlife in our backyard, as much as we appreciate it, it's really cool to see all these species in our backyard. At some point, there's this switch from being interesting to being a nuisance. And so we're seeing that a lot throughout Connecticut, where especially with larger, more predatory species. So bear tends to be the ones that we see a lot, or even deer that come in and they seem to demolish people's ornamental plant species in their backyard. With this draw for species to leave the woodlands and inhabit people's backyards, and then, like I said before, becoming more tolerant of people, more habituated to their surroundings, and sometimes even dependent on the surroundings, they're going to become a nuisance. And then the last thing we want to do is see these animals suffering as a result of the fact that we no longer can accommodate them in our backyards, that we no longer could handle them, or we feel threatened by them. So the big draw being that we need to kind of reestablish and rebalance this healthy woodland environment to draw these species back in, to reduce our pathogen presence, and ultimately to negate them becoming a nuisance species in our backyard, because they are really cool. I mean, these pictures are super fun to look through because you have this huge diversity. You can see all the different levels, from lower level prey to upper level predator, and the interactions between species. Like, this is a great photo. You can see him. This cat is very excited that he got dinner. So we just don't want to see that happen. And we also want to identify the fact that by creating this healthy woodland ecosystem, we can reestablish the diversity in there. And we're seeing that diversity really does drive down pathogen presence. So if we can bring that into the woodlands, it's only going to further help that reduction in pathogen presence. It's only going to further help us as a community. Because when you have a healthy forest, you end up having a healthy public. And so who doesn't want to see a reduction in Lyme disease cases, and also see these animals survive and thrive in the habitat that they're designed to be in? So I think that it's really important that we work as a community, as well as just the work that I've been doing since graduating with a great group of people, is working on approaching this from all angles, you know, and really reestablishing the healthy woodland ecosystem that all of us kind of want to live in here in the Northeast, as well as throughout any of our other states and globally. And like I said, I think if we focus on this and really drive that home, and we'll have not only this healthy forest, but healthy people too. It's a really interesting connection to make. So with that being said, I didn't do any of this by myself. I have this amazing team of people at the Connecticut Agricultural Experiment Station, and so I have to give them all a shout out, because they help from the big to little things, everything in between. And then I think I mentioned this at the beginning, but this is all of my communication and contact information. Like I said, I am a vector ecologist, so I primarily focus on Lyme disease ecology, but I look at a bunch of different zoonotic and vector-borne diseases if you have any questions. We also have a lot of great resources at the Ag Station website if you want to learn more about ticks or tick management, or even just stuff in your backyard that you can do. And then with that being said, I think that's the end. That was quick, so hopefully we have lots of time for questions.
So let's see what we have for questions. I don't have any questions on Facebook right now, so if anyone does have any questions, please put them up. And we have a question. Does this include early succession woodland establishment? So I'm not sure what that's referring to. I'm
assuming it's referring to the woodland sites that we used. So we predominantly used, I'm trying to think, we had, early succession forest was accommodated into our woodland sample sites, if that answers the question. Yes, we had the full spread of different woodland areas that were currently undisturbed by human development.
Okay, and we have another. What kind of things are your team doing to improve woodlands?
Great question. So we have done a lot of invasive management control. So when I started my career at the Ag Station, we predominantly worked on Japanese barberry control. So I'm sure if you've seen myself or any member of my team in talks before, you've heard about Japanese barberry is an invasive ornamental plant species that was introduced and kind of took over forest understories in disturbed soils, so a lot of like previously agricultural lands, and it's positively related to black-legged ticks. So it provides this unique microclimate that allows ticks to be out for longer periods of the day. So they have a greater questing opportunity, greater opportunity to run into wildlife and obtain their blood meal. And so we found that in these areas, there was a greater number of ticks, and there's also a greater number of infected ticks. So the past 15 years, the Ag Station has been conducting habitat modification efforts and also educating people on Japanese barberry removal strategies to, one, remove a really aggressive invasive plant species, but also to remove that ideal habitat for black-legged ticks. So those are big ones for management. And that's just one invasive species. We are trying to incorporate all invasive plant species that are kind of affecting woodland health.
All right, we have another, considering, I'm going to do this a little out of order, but okay. Considering that Connecticut is 93% private, should we be more actively developing private land forestry programs?
That's a great question. I would say yes. Optimistically, I think that, like you're pointing out, Connecticut is a unique situation in a small state with a lot of privately owned land. So I would say yes. Yes, I'm going to end with that. Yes.
What's the best way to avoid ticks attaching to you in the outdoors? That's
a great question. And it's funny, with all the gadgets and things that come out, the best thing you could possibly do is a tick check when you come home. So me and my team are obviously out in very ticky habitat all the time, and I really credit our lack of tick attachment and infection because we're constantly checking, not only when we come home, but when we're out in the field, knowing when you're walking through the woods, if you brush up against any vegetation, there's a likelihood that you could encounter a tick. So just wearing long pants, socks pulled over the top of them so they can't get directly to your skin, gives you an opportunity to see if anything's crawling up your legs, and then removing them. Another thing that we've been using in the past couple of years that seems to be pretty effective is tick repellent laden clothing. So a company that we have used is Insect Shield. They have socks, gaiters, pants, that sort of thing. There's a bunch of different companies out there that you can utilize, but if you're looking for something that could really help if you're out in the woods a lot, that definitely has helped us in the past, and we use it quite frequently. But definitely tick checks. And then the other thing too is if you have, I think people forget about their dogs and cats bringing in a lot of ticks into their house. So they might be like, well, I don't go out in the woods that often. But if you have outdoor animals that come in, even if they're treated or wear the collars, ticks can just still be on their fur, and then they drop off, or if they're rub up against you, they can reattach to you. So just making sure not only to check yourself, but also check your dogs, cats, that sort of thing.
That's a great point.
Yeah.
It's just looking. You just have to keep looking.
Yeah, honestly. And I know it's like whenever we find them, we all get the heebie-jeebies, and then we're like hyper vigilant. But definitely, it's amazing. Just that simple task really, really helps. And then actually, one of my coworkers swears by the fact that when he comes home from work every day, he takes his pants, shirt, socks, and he throws them in the dryer on super, super high heat, or just high heat, not super high heat. That's not a setting. But so ticks are very, when it comes to temperature, they're very fragile. And so they're, if you turn the heat up high enough, they actually just like dry out crisp up and they die. So if you're worried that there's some on your pants or socks or your shirt that you didn't catch, you can always take those clothes and just throw them in the dryer.
That's a good tip.
Yeah, it works.
So I'm going to combine a couple of other questions here. In order to, so there's a two-part question here. In order to establish a healthier woodland, you mentioned that there were not enough species diversity for a healthy forest system. What species are missing from a forest, and what might be good species that people could plant to promote that?
Oh, that's a good question. So I thought this was talking about wildlife species, but it sounds more like it's plant species is what I'm taking away from it. So it's not so much about what to plant as it is proper management, if that makes sense. So as I had stated earlier, a lot of our current woodlands are really mature old woodland stands. And the reason that they're not becoming healthier is because anything on lower levels can't compete with the higher level foliage for the sunlight nutrients that it needs. So a lot of that stuff isn't getting down to the forest floor. So that's the first step. So proper management of those older mature stands to allow for younger ones to come in, that's the first step. The second step is not so much planting as it is removing. So once again, that's tying into the invasive plant species aspect. There's a lot of invasive plant species that take over that understory. So any younger native plant species that have an opportunity to kind of get through are being outcompeted by the native or the invasive plant species. So this is once again like that Japanese barberry, that sort of thing. If you ever see it, it's a incredibly dense thicket, and it just takes over the entire understory. There's very few other species that are able to compete with it to get out of it. And so with the combination of not getting adequate resources from the mature native woodland species, but then also not having opportunity to get out of the invasive layer makes it really, really difficult for them to reestablish. So I know I'm going to add one more thing, threefold. So we got the canopy, we've got the invasive, but it's also properly managing species like white-tailed deer. So if that one little sapling somehow gets enough sunlight, outcompetes the invasive plant species, then they also have to worry about a deer coming in and eating them. So in an area where deer are vastly overabundant, we also need to moderate that species as well, or manage that species as well. So it's not so much as what can we plant, but what can we manage. And then as a tangent to the invasive plant species, if you're going to plant things in your backyard, I would just really pay attention to what ornamental species or exotic species you're introducing, because Japanese barberry is still, I believe, still sold in as an ornamental plant species, and if not properly maintained within your backyard, can quickly overtake the area. So just something to keep in mind when you're shopping for landscaping.
Yeah, the greenhouses do have a banned species list, but I know that all they have to do is hybridize it, and then they get around that ban. So
right. So it's just, you know, doing your research, your due diligence when you're planting species in your backyard for sure.
okay, next question. Redding properties might be quote unquote more woodsy than other residential areas. Do you see similar results in more densely populated residential areas?
So there's definitely a gradient for sure in Connecticut as well as many other states, but I found that Redding is a nice representation of a lot of our residential areas in Connecticut. A vast majority of them look pretty comparable. However, of course, you're going to find things on both ends of the spectrum and everything in between. In areas where it's much more densely populated and you don't see that kind of woodland edge. I think that's a good point to make, is you need to have the opportunity for wildlife to come in. So in a more densely populated area that might not have that woodland residential interface, you might not see some of those other species like bobcats and bear and that sort of thing. But you'll still see a lot of other species. Like a lot of them are very resilient, and you'd be surprised at how many places you'll find deer, fox, the passerine species, and especially other small mammals too. I mean, we all have squirrels, mice, chipmunks, that sort of thing in our backyard. So you might not see as many, but I bet you'd see a fair amount.
Very good. Do you recommend sending every tick you find attached to your skin in for testing?
That is a great question too. So we do have a tick testing facility at the station. If you ever want to have a tick tested, I highly recommend it. You have to just send it through, I believe, your doctor, your public health official. But no, not every tick should be tested, and I'll tell you why. Specifically with the black-legged tick, in order for them to transmit any pathogens to you, they need to be attached for 24 to 48 hours. And the reason for that is because the process in which they uptake a blood meal is, there's a couple steps to it, but basically they take in a sip, they spit out a sip, then they take a really big gulp. And that really big gulp, they become engorged. And so typically at 24 to 48 hours is when you start to see that engorgement. So if you find a tick on you and it's pretty flat and it doesn't look like there's much matter in that gut part, that reddish image that we saw, and I think, here I can go back to, ooh, we're going fast. I'll show you a picture of, my goodness, so many things. So, oh my goodness. So this, for instance, this is a picture of a female that you might find attached to you that's unengorged. So if it looks like that, chances are, if you submit it, we can't test it, or there's no reason to test it anyways because it has not been attached to you for long enough. But if you find a tick on you that is engorged, that means it's had enough time to obtain that blood meal, which means it also has had time to pass pathogens to you. So if you want to send it in at that point, then we can test it and tell you if it has something, you might possibly have something. So that's a really great question, because a lot of people think that even if they find a tick just crawling up their leg, that it should be tested, and that's not the case.
Very good. And I was curious how to get it tested. So it's through your doctor or local health.
Yes, and so once again, if you go to the Ag Station website, there's a whole tick testing page that you can look at, and it tells you the steps to do it and that sort of thing. And it's very, I've had it done, and I've had one tested for my nephew too, so it works for sure. It definitely helps. But with that being said, don't wait to get, like, if you submit a tick, don't wait for the test results to come back. If you have an engorged tick, also go get tested at your doctor as well for any of the diseases that might come from it, because it does take a little bit of time. So I would suggest that if you find an engorged tick on yourself, you can submit it, but also go get tested at your doctor's office.
Very good. Here's a question. Are invasive snake worms a big problem in Connecticut, destroying the understory of our woods?
This is the first time I've heard of the invasive snake worm. So I'm going to say that, to my knowledge, I don't know that it's a huge issue, but I'm going to write that down and look into it further, because now you've piqued my interest. I know we have a lot of other invasive pest species, so it might be on our list, but I have not done research on it, so I can't speak to that matter. But
Yeah,
thank you.
I'm not familiar with that one either.
Yeah.
And our last question, if the heat of the dryer can kill the ticks, does a very hot day outside hurt ticks?
That's also a great question. So yes, and that's where we're having issues with things like invasive plant species, because if you have ticks that are out and there's a really dry, hot snap, it will kill off like if we have a really hot, dry summer, you would expect to see tick populations to decline. However, when you have species like invasive species like Japanese barberry, what they do is they trap a lot of the humidity that's in the air, because they have this unique umbrella-shaped growing pattern. And so if there's ticks under that umbrella-shaped growing pattern, they're trapped in that nice humid temperature, like basically a temperature-controlled area. And so their probability of surviving a hot, dry snap has increased, which is why we're seeing more and more of them in those areas that are invaded by Japanese barberry and other invasive species. And then to counter that point, you can also see the same thing in really cold, dry winters too. So once again, if you want to visit my page at the Ag Station, you can see a couple different publications we've had relating tick survival to winter temperatures. So if you have a really cold, dry winter, that'll also induce or increase mortality among ticks, and you'll see a reduction in them in the following spring as well. So yes, they're very, very, we call it desiccation-induced mortality. They're very susceptible to extreme temperatures and dry climate.
Wow, that was fascinating. I want to thank you very much for the presentation. I want to thank everybody that tuned in today and remind you that the next Saturday, we've got bats, then we've got beavers, then we've got fisher. So lots more wildlife programs coming up. Those are Saturdays at 10 o'clock. And please sign up on our calendar at meigspointnaturecenter.org for updates. And then you won't have to log into the calendar. You'll get a notice when we have a new program posted. So again, thank you very much. I want to thank everybody for watching. And this is Ranger Russ from the Meigs Point Nature Center. We are signing off.
Thank you.